All right, hopefully this time when I record this, it will finally work. That would be wonderful if that would happen. So we'll have to wait and see. So we're looking at remainder and factor theorems. This is day 1. I believe there are 3 days because I've decided to split them up. What we're going to look at today is if we have some kind of polynomial and I would like to divide it by, we're just going to look at dividing by a binomial today, meaning it has 2 terms. So this one here we're going to try and divide 2x to the 4th minus 9x squared plus 17x plus 3, and we're going to try and divide it by x plus 3. And today we are going to use long division. I know that a lot of you in here have a preferred way that is not long division. Okay? And we are going to talk about that one tomorrow, which is synthetic division. But the problem is synthetic division doesn't always work as well. Long division, if you do it properly, will work right every time. But let's face it, sometimes doing it properly is not as easy as it sounds. So let's first just set up what a long division problem would look like. Okay. Well, hopefully your line's a little straighter across than that. So I'm trying to divide by x plus 3. That's what I'm trying to divide out. Okay. Now there's no guarantee that it's going to divide out evenly, because basically if you look at our polynomial we're looking at, x to the 4th is degree 4, right, from yesterday, if you remember that? That means it does have 4 little factors or 4 little pieces to it. We're kind of trying to find out, is x plus 3 one of them? Okay, maybe it is, maybe it isn't. We're not really sure yet. And so what we're going to do is we're going to write it in here. So we got 2x to the 4th. Yeah, I've paused there because we are missing one of the terms. And so we got to make sure that it goes in descending order. So here's to the 4th power, right? We are missing the 3rd power. Now it really doesn't matter if you put plus or minus, because you are going to put 0x to the 3rd. Because that's the only way I can insert an x to the 3rd term without changing the polynomial. Okay, otherwise, if I put something else like 1x to the 3rd, then it's completely different. So then 9x squared would come next if we keep going down in order. And then 17x. Again, this is called descending order. Okay. So that's the general setup for long division. So now what you do is you go in here and you look at this 2x to the 4th term that we have, and we know it is x to the 4th for sure. So we know there are 4 pieces, and what we're going to try and divide out is this piece right here. Just worry about this for right now, just the x. And really it's just 1x, and it's to the 1st. So if I were to write that off to the side, you don't have to, but it's basically I'm trying to take that, just the 2x to the 4th, and divide it by 1x is really what I'm trying to do. Okay, I want to find out what's the result of that. And it's easiest, why don't you just take a look at the numerators? It's not the numerator, well, the coefficients is probably what I should say. So it's 2 out front right here over 1, right? Well, what is 2 divided by 1? Well, that's just 2. That's not too hard, so you put that here. This is x to the 4th up here divided by x. Well, remember, x to the 4th really means x times x times x times x, correct? And basically I'm dividing it by an x, so I am left with x to the 3rd. Now, does that make sense? If I had 4 of them to begin with, and I'm trying to take one of them out, does it make sense that there should be 3 left? It kind of does. Okay, that's why it is x to the 3rd. Okay. Here is, I believe, where most people start to make their mistakes in long division. I think a lot of people can kind of get that first term, and then all of a sudden things go a little haywire. Okay. What you have to do is you got to find out, well, how close to this big long piece did I get? How close to this 2x to the 4th plus 0x to the 3rd minus 9x squared plus 17x plus 3, how close did I get? Okay. So what you do is you take the 2x to the 3rd and you multiply it by 1x, and that is 2x to the 4th. And it better be. That first term better match up. If you did it right, it will. Okay. Now it's this other piece that a lot of people forget about. Okay, I got to find out, did I make it? Is it perfect? Well, let's find out. Let's take 2x to the 3rd, and we have to take it times 3. That is 6x to the 3rd. So now where would we most logically line that up? I could put it anywhere. I could put it over here, or here, or here, or here. But there is probably a logical place to line up the x to the 3rd term, which is right there. Are we in agreement so far? Any questions? Now, if we combine the terms the way they sit right now, If I add these, this would be what? 4x to the fourth plus 6x to the third. Did I get rid of anything at that point? No, I really haven't made any progress at all, and that's not why we do this. Because you agree, this right here is how close I got. Was it perfect? Did it match everything perfectly? No, it'd be great if it did. We'd be done, right? It didn't. So this is how close I got. So that's why you go in and you basically subtract whatever this is, because we're going to take it away because that's how close we got. So let's subtract that. This was positive, this 6x to the third, so let's subtract that as well. So it's 2x to the fourth minus 2x to the fourth. X to the fourth is gone because you have none of them. So we've got 0x to the third minus 6x to the third is negative 6x to the third. That right there, relatively quickly, is the process. It is the process you keep repeating. Now, what a lot of you like to do, and this almost always works, so there's a few cases where it gets a little weird, is basically we only have one term down here, and we have two terms up here. And so what's the logical way of fixing that problem is to bring another term down. Can you just bring whatever term down you want? Well, technically you can. You can bring them all down if you feel like it. You could rewrite all of these terms down here if you wanted to. But most of us choose not to, right? I know I do. So let's just bring down the next term. Negative 9x squared. Now you start the process all over again. Right? So we've got negative 6x to the third down there, which I'm really trying to divide by 1x to the first. So negative 6 divided by 1 is negative 6. X to the third divided by x. Again, it's x times x times x is what x to the third is. Take away one of those, it's x squared. Everybody see where the x squared came from? So now, again, the easiest spot to miss. You got to multiply it back down and see how close you got. So negative 6x squared times x, negative 6x to the third. And please do not forget to take negative 6x squared times that kind of tag-along piece, this 3 over here. Okay? So negative 6x squared times 3 is negative 18x squared. So did I bring down the right term? I did, because it's x squared and x squared, so that worked out pretty well. As they sit right now, if I were to combine those terms, I don't get rid of x to the third, though. So here's where you have to go in and really subtract what you have there. But this one, this very first one here, would be subtracting a negative, which really means to just add it. Okay? Same thing here, subtract the negative, so add it. That's why I think a lot of you are probably taught go in and just change the sign. On that second one is probably how most of you were taught that. Okay. This is gone. What are we left with here? 9x squared. And again, technically, you could bring down all the rest of the terms if you wanted to, but we probably won't need them all. That's why a lot of times you just bring down the next one and you hope it works. This time I brought them both down to show you that it's still going to be okay. And now you start the process over. And now what we're trying to divide is this, 9x squared divided by, not divided by the 2x to the third that's on top, not divided by the negative 6x squared that's on top, but divided by the 1x that we're dividing by over here. 9 divided by 1, that is most definitely 9. X squared divided by x. Well, x squared means x times x, taking one of the x's away, so it's 9x. Now let's take, ooh, that's new. Now let's take 9x times both of these pieces over here. 9x times x, 9x squared. All right, a little delay there, but it's working. And then take 9x times 3, what is that, 27x? So we would line that up here. Okay. Yeah, we're going to go through, change your signs. All right, x squareds go away. What are we looking at? Negative 10x. Bring down the plus 3. And you start over. Negative 10x. Again, divided by this 1x. Negative 10 divided by 1 is negative 10. X divided by x is gone. All right, so that must be it, right? It worked. How do we know it didn't work? Well, we haven't really checked yet, have we? We got to multiply back on, and hopefully it matches perfect. Well, we'll find out. Negative 10 times x, negative 10x. We're doing good so far, down here at the bottom. And then we take negative 10, that's way over there on the right, times this 3, that's right here, and we get negative 30, unfortunately. Okay. So now here's where some people will mess up the remainder. You do still have to go in and change your signs or subtract what you have. So it looks like 33 is the remainder. So there's many ways you can write the remainder. Probably the most common is just put remainder 33. Or really what you could write is that the answer is 2x to the third minus 6x squared plus 9x minus 10. And then you could kind of put plus 33 divided by x plus 3, because I'm still trying to divide 33 by x plus 3. Okay, so you can write it that way as well if you'd like, because technically it just didn't work out, and I can't. Okay. So that's long division. So based on what we saw there is a remainder. So is x plus 3 one of the 4 pieces or four factors that made up that polynomial? It can't possibly be, because if it was one of the pieces, the remainder would have been 0. Okay. And it was not. Okay. Any questions on the long division? Okay. What I would like you to do right now is, why don't you try example 2 that is on the back. I will pause the recording, and anybody listening to the recording should probably also pause it and actually try it instead of just continuing with the... Well, apparently, depending on how the copies were made, you have to make sure if it says x plus 4 or x minus 4 on your sheet. So make sure you take a look at that. So is x plus 4 a factor? Again, that means, is x plus 4 one of the pieces that created this particular polynomial? Okay. And how many pieces did it take to make this particular one? How many pieces did it have? Or does it have? Yeah, exactly. I see a lot of people saying 4 out there, or showing 4 with their hands. So to start it off, again, there's lots of ways, and I know you probably prefer synthetic. Synthetic would have worked for both of the ones we had today really well. Synthetic doesn't work so well on some other ones. So x plus 4 is what we would like to divide by. And we got x to the 4th is the highest, then x to the 3rd comes next, followed by x squared, and then x. So this time you didn't have to worry about any missing terms. Okay. And the reason we put those in is because, like last time we had that extra stuff that came in at the bottom, we had this 6x to the 3rd right here, and had we not had something above it, we would have been really lost because we wouldn't have known where to line that up. Okay. So here we go, x to the 4th divided by x. Well, 1 divided by 1 is 1, and x to the 4th divided by x is x to the 3rd. X to the 3rd times x, x to the 4th. X to the 3rd times 4, I don't know what that is plus 4x to the 3rd. Okay, we got to take away how close we got. Right, so we got what, negative x to the 3rd then? Again, you could bring down all of these terms, but we'll just try this, see how well it works. If I need to, I can always bring down more terms. Okay, so negative x to the 3rd divided by this x that's over here on the left, this one over here. And we got negative 1x to the 2nd. So negative x to the 2nd times that is negative x to the 3rd. And negative 1x to the 2nd times that is negative 4x squared. And change them. And what do we got there? 3x squared. Again, you can bring down any term you want. But we'll just try that one. So if we divide 3x squared by x, we get, what, 3x? So 3x squared plus 12x. Change your signs. And that's negative 1x. Bring down the negative 4. Negative 1x divided by x is, this is looking pretty good, negative 1. If you take negative 1 times x in front, you get negative x. Negative 1 times 4 is negative 4. So if you move too quickly, you may say that the remainder is negative 8. Okay, but it is not, because you do have to remember to change your signs. The remainder is 0. What that means is that x plus 4 divided out of there evenly. It divided out perfectly. And any factor of a polynomial will divide out evenly. Okay? So here it says, is it a factor? Then truly the answer to this question is yes, because the remainder was 0. It divided out perfectly. Okay? Any questions on that? Okay, I'm not asking you for the other 3 factors yet today. That'll be later on in this chapter. Just want you to let me know, how about this one? Is this one a factor? And it is. Anything else?